Article 450.10 of the National Electrical Code, or NEC, mandates the grounding of secondary circuits in transformers that power Class 2 or Class 3 circuits. This regulation exists primarily to maintain a safe potential within the secondary circuit, especially in the event of a fault condition. In your specific scenario, the 24 volts alternating current secondary of the control transformer is designated to supply a Class 2 circuit. Consequently, adherence to Article 450.10 necessitates the grounding of the X2 terminal on the transformer. The X2 terminal represents the midpoint of the secondary winding. Grounding this terminal is crucial to limit the voltage between either side of the secondary and the ground to a maximum of 12 volts alternating current. This grounding practice significantly enhances safety by minimizing the risk of electric shock. While there are exceptions to this grounding requirement, they do not apply to typical Class 2 circuit applications. The purpose of grounding the secondary is multifaceted. Firstly, it ensures personnel safety by limiting the voltage to ground. Secondly, it provides a path for fault current to flow back to the source, facilitating the operation of overcurrent protection devices like circuit breakers or fuses. Thirdly, grounding helps to reduce electrical noise and interference, improving the overall performance and reliability of the connected equipment. Grounding the X2 terminal involves connecting it to a grounding electrode conductor, which in turn is connected to a grounding electrode system. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or underground metallic water pipes. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the ungrounded conductor supplying the transformer. The grounding electrode conductor must be securely connected to the grounding electrode system using approved methods such as exothermic welding or listed connectors. When installing the grounding electrode conductor, it is essential to ensure that it is protected from physical damage and installed in a manner that minimizes the risk of corrosion. The grounding electrode conductor should also be routed as directly as possible and without sharp bends or kinks. In addition to grounding the X2 terminal, it is also important to ensure that the transformer enclosure is properly grounded. This is typically accomplished by connecting a grounding conductor from the enclosure to the equipment grounding conductor system. The equipment grounding conductor system provides a low impedance path for fault current to flow back to the source, helping to clear ground faults quickly and safely. The size of the equipment grounding conductor is determined by NEC Table 250.122, based on the size of the overcurrent protection device protecting the circuit. It is crucial to verify that all grounding connections are tight and secure. Loose connections can create resistance, impeding the flow of fault current and compromising the effectiveness of the grounding system. Regularly inspecting and testing the grounding system is essential to ensure its integrity and reliability. This includes checking for corrosion, loose connections, and proper grounding electrode resistance. The NEC provides detailed guidelines for testing grounding systems, including recommended test methods and acceptable resistance values. By adhering to these guidelines, you can ensure that the grounding system is functioning correctly and providing adequate protection. When working with electrical systems, it is always important to prioritize safety. Wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. De-energize the circuit before working on it whenever possible, and use a voltage tester to verify that the circuit is de-energized. If you are not comfortable working with electrical systems, it is best to consult a qualified electrician. Article 450.10 specifically addresses the grounding of transformer secondaries, highlighting its importance for safety in Class 2 and Class 3 circuits. The code mandates this grounding to limit voltage to ground, ensuring personnel safety and facilitating the operation of overcurrent protection devices. Proper grounding practices also contribute to reducing electrical noise and interference, thus enhancing the reliability of connected equipment. To comply with Article 450.10, connect the X2 terminal of the 24 volts alternating current secondary to a grounding electrode conductor. This conductor should then be connected to a grounding electrode system, which includes ground rods, ground plates, or metallic water pipes. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the ungrounded conductors supplying the transformer. Ensure that all connections are secure and that the grounding electrode conductor is protected from physical damage and corrosion. In addition to grounding the XDU terminal, ground the transformer enclosure by connecting a grounding conductor from the enclosure to the equipment grounding conductor system. The size of the equipment grounding conductor is determined by NEC Table 250.122 base and the size of the overcurrent protection device protecting the circuit. Regularly inspect and test the grounding system to ensure its integrity and reliability, checking for corrosion, loose connections, and proper grounding electrode resistance. Always prioritize safety by wearing appropriate personal protective equipment and energizing the circuit before working on it. If you are not comfortable working with electrical systems, consult a qualified electrician. Proper grounding is crucial for personnel safety, equipment protection, and system reliability. By following the guidelines in Article 450.10 and other relevant NEC sections, you can ensure that your electrical systems are properly grounded and provide a safe and reliable operating environment. The rationale behind grounding the XDU terminal in a 24 volts alternating current Class 2 control transformer involves several critical aspects. Firstly, safety is paramount. Grounding the secondary winding limits the potential voltage to ground, reducing the risk of electric shock if a person comes into contact with the circuit. Secondly, a properly grounded system provides a path for fault current to flow, enabling overcurrent protection devices like circuit breakers or fuses to quickly and safely interrupt the circuit in the event of a fault. Thirdly, grounding minimizes electrical noise and interference, which can disrupt the operation of sensitive electronic equipment connected to the circuit. When selecting a control transformer for this application, consider factors such as the required volt-ampere rating, the primary and secondary voltages, and the insulation class. The volt-ampere rating should be sufficient to handle the load imposed by the time delay relay and any other connected devices. The primary and secondary voltages should match the available supply voltage and the voltage requirements of the connected equipment. The insulation class should be appropriate for the operating environment, considering factors such as temperature and humidity. When installing the control transformer, follow the manufacturer's instructions and all applicable electrical codes and standards. Mount the transformer securely in a suitable enclosure, ensuring adequate ventilation to prevent overheating. Connect the primary and secondary wiring using appropriate conductors and connectors, following proper wiring practices. Ground the transformer enclosure and the XDU terminal of the secondary winding as required by the NEC. After installing the control transformer, thoroughly test the circuit to verify that it is functioning correctly. Check the primary and secondary voltages, the current draw, and the operation of the time delay relay. Verify that the grounding system is properly installed and functioning, and that all connections are tight and secure. Regularly inspect and maintain the control transformer and the associated circuitry to ensure continued safe and reliable operation. Check for signs of overheating, corrosion, or damage, and replace any defective components promptly. Test the grounding system periodically to verify its integrity and effectiveness. By following these guidelines, you can ensure that the 24 volts alternating current Class 2 control transformer is properly installed, grounded, and maintained, providing a safe and reliable power source for the time delay relay and other connected equipment. Furthermore, understanding the NEC requirements and the reasons behind them is essential for ensuring compliance and promoting electrical safety. Grounding the XDU terminal is not just a code requirement, it is a fundamental safety practice that protects people and equipment from the hazards of electrical shock and fire. The National Electrical Code serves as the cornerstone for safe electrical installations. Article 450 specifically addresses transformers, and within it, Section 450.10 mandates grounding under specific conditions. Understanding the nuances of this requirement is paramount for electrical professionals. Grounding the secondary of a transformer, especially in Class 2 and Class 3 circuits, serves a critical safety function. Without proper grounding, a fault in the system could lead to elevated voltage levels, posing a significant shock hazard. Grounding provides a low impedance path for fault current to flow back to the source, tripping over current protection devices and quickly de-energizing the circuit. In the case of a 24 volts alternating current class 2 control transformer, grounding the X2 terminal ensures that the voltage between either side of the secondary winding and ground is limited to a safe level, typically 12 volts alternating current. This effectively minimizes the risk of electric shock. The NEC outlines specific requirements for grounding electrode systems. These systems typically consist of one or more grounding electrodes, such as ground rods, ground plates, or underground metallic water pipes. The grounding electrode conductor connects the transformer's X2 terminal to the grounding electrode system. The size of this conductor is determined based on the size of the ungrounded conductors supplying the transformer, as specified in NEC Table 250.66. Proper installation of the grounding electrode conductor is crucial. It should be protected from physical damage, installed in a way that minimizes corrosion, and routed as directly as possible without sharp bends. In addition to grounding the X2 terminal, the transformer enclosure itself must also be grounded. This is achieved by connecting a grounding conductor from the enclosure to the equipment grounding conductor system. The equipment grounding conductor provides a low impedance path for fault current to flow back to the source, facilitating quick and safe clearing of ground faults. The size of the equipment grounding conductor is determined based on the size of the overcurrent protection device protecting the circuit, as specified in NEC Table 250.122. Maintaining a robust grounding system is essential for continued safety and reliability. Regular inspection should be conducted to check for corrosion, loose connections, and proper grounding electrode resistance. The NEC provides guidelines for testing grounding systems, including recommended test methods and acceptable resistance values. When working with electrical systems, safety should always be the top priority. Appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools, should be worn. Whenever possible, the circuit should be de-energized before any work is performed. A voltage tester should be used to verify that the circuit is de-energized. If you are not comfortable working with electrical systems, it is always best to consult the qualified electrician. The requirements in Article 450.10 for grounding the secondary of transformers are based on sound engineering principles and extensive experience in the field. These requirements are designed to protect people and equipment from the hazards of electricity. By understanding and adhering to these requirements, electrical professionals can ensure the safety and reliability of electrical systems. The grounding of the X2 terminal on a 24 volts alternating current Class 2 control transformer is a fundamental safety practice. It limits the voltage to ground, provides a path for fault current, and minimizes electrical noise. Following the NEC guidelines for grounding electrode systems, grounding electrode conductors, and equipment grounding conductors ensures a robust and effective grounding system. Regular inspections and maintenance are essential for maintaining the integrity of the grounding system, and always prioritize safety when working with electrical systems. Understanding the principles and practices of grounding is essential for all electrical professionals. It is a critical aspect of electrical safety and is essential for protecting people and equipment from the hazards of electricity. Proper grounding not only protects against electrical shock, but also helps to prevent fires and equipment damage. By adhering to the NEC requirements and following best practices, electrical professionals can ensure the safety and reliability of electrical systems for years to come. The NEC is a comprehensive document that covers a wide range of electrical topics. It is essential for all electrical professionals to have a thorough understanding of the NEC and to stay up to date on the latest changes and revisions. The NEC is constantly evolving to reflect new technologies and best practices. By staying informed, electrical professionals can ensure that they are providing the safest and most reliable electrical systems possible.